Hi, for our first demonstration, making electricity from thin air, we're going to practice the first principle of taking on the role of a scientist. Scientists first observe the phenomenons that occur, then they'll make some questions and try and answer how these miracles and mysteries happen, and finally, they'll discover the truth behind the science. In a classroom, you can take this copper wire and explain to your students that the material used here is just a big bundle of copper wire, and we also have a galvanometer, which is a tool to measure if electricity is flowing. If there is electricity flowing, the needle on the galvanometer will move. So the first thing we want to do is get our students engaged. So we'll take this wire and we'll ask students to move it side to side and ask them to observe what happens to the galvanometer. This is great to move around the classroom and get all students involved, so just passing it to them, maybe even when they walk into class, or having groups sitting at tables and just handing it off to each one. And this is a good way to get them to use their hands to really be a part of the science that they're doing. After you ask them to observe what happens to the needle while they're moving it, they should be able to answer that the needle's moving. After they make these scientific observations, they can go on to question and hypothesize how it occurs. As scientists, it's really important to encourage all types of answers, no matter how silly, so that we can hopefully engage some type of idea that may be the right one. Students may answer with silly answers such as the air all around us, or maybe their muscles are really strong and they got the needle to move, or maybe there's gravity that's occurring around it and causing the needle to move. Although these are all good answers, the right answer is that this wire is interacting with Earth's magnetic field. When talking about Earth's magnetic field, it's good to use visualizations, such as the ones that are attached in our lesson plan and the seminar presentation, so that students can see that these magnetic field lines that surround Earth are all around us, even in your classrooms. So we take our observations of the needle moving, then we question how it occurs, and finally we discover that moving this wire through the Earth's magnetic field generates electricity. For demo number 2, it's all about magnetic discoveries. The materials for demo 2 are magnets. For this demonstration, you should pass out 2 magnets to each student in your classroom. The principle behind this demonstration is, again, to use our scientific minds and practice the scientific method. After each student gets 2 magnets, encourage them to play around and observe what occurs to the magnets when they bring them closer together, and what happens when they flip the magnets and then try to push closer together again. After playing around for a few minutes, students will have observed the magic behind magnets. A good thing to do next is to question, how does this occur? So then, students will understand that maybe there's something between these magnets that cause them to touch. Some people may think it's an invisible force. After hypothesizing what the magic behind magnets are, students can then discover, with your help, that magnets are symmetrical, and they have a balance between having an attractive force, which brings them together and pulls them close, and a pulling force, which causes them to repulse from each other. Throughout demonstration number 2, students will have learned the scientific method and also have been exposed to the magnets, the magnetic force, and the magnetic field that surrounds a magnet. A pro tip for the end of demo number 2 is to make sure that you leave demo number 1 out on the table so that students can maybe play around and incidentally take a few magnets and bring it near the copper wire. Now, we learned in the first demonstration that if a magnetic field is present and if this wire is moving through the magnetic field, that the galvanometer will change and show that there is electricity flowing through it. So, if all magnets really do have a magnetic field, if we take all these magnets and put it through this wire, the needle on the galvanometer should change and show that there is an electric current flowing through it. Let's see what happens. So by moving these magnets through this wire, we can confirm that all magnets have a magnetic field surrounding them. For our third demo, we're going to prove that the magnetic field is real. So we'll take out our magnetic field cubes and also separate the magnet from the field cube as well. In groups of 4 to 5, you can pass out the magnetic field cubes and ask one student to be in charge of shaking the magnetic field cube and holding on to it. You can ask another student to be responsible for holding the magnet. Inside the magnetic field cube are some iron filings that are also suspended in an oil type of material. Since iron is a metal, it has magnetic qualities to it. When students are in groups, you can ask one student to take the magnetic field cube and shake it up. Then ask another student to drop the magnet into the core of this magnetic field cube. Then they're going to assume the role as scientist and observe what occurs. As they're developing their observations, it's encouraged that they talk about it or maybe write it down. After observing that the iron filings kind of organize in a pattern around the magnet in the magnetic field cube, we're going to question, how did that happen? So this is a chance for our scientists to create hypotheses on the science behind magnets. After making some hypotheses, our students are then encouraged to discover the truth behind magnets, which is, just like Earth, all magnets have a magnetic field surrounding them. And this magnetic field cube allows us to visualize the field lines that surround all magnets and even Earth itself. This is a good time to use visualizations to help the understanding of magnetic field lines by using the pictures that are used in the lesson plan attached and also the seminar slideshow. For the fourth demonstration, we're going to use our light rings. Our light rings are constructed with some copper wire, some LEDs attached to the center. We also have a magnet, and we've attached that to some wood. The principle behind using the light rings in a classroom is to show that you can't get something from nothing, and moving a magnet through a coil of wire creates electricity. The demonstration method for demo number 4 requires groups of 3 to 5 students and one light ring per group. Students in this group will then test and observe what occurs to this device when they take the magnetic wand and pull it through the copper wire quickly. For this part, students are now engaging their engineering side. So from what they learned as scientists, they're now applying it into an engineered application. With this device, students are learning that there's a transfer of energy from the motion of their arm to the wire that goes into the lights. So students can't get something from nothing. They have to put energy from themselves to make this light up. For demonstration number 5, we have our shake light straws. This demonstration transforms students from the scientists that they were earlier on into engineers. This demonstration draws upon the principle that electricity is energy and we can all make electricity. What we have are shake light straws in a vial, and the only things in here are a magnet, some copper wire that has been spun around this clear straw, and an LED light that's attached to the wire. For this demonstration, in your classroom, the method is to pass one of these vials out to each student. And each vial has different colors, so there's a grouping of white LEDs, red LEDs, orange LEDs, green LEDs, and blue LEDs. When you're showing this to your students in a classroom, ask them to hold on to it. Then go ahead and turn off the lights in your classroom. On the count of 3, you can ask all your students to vigorously shake their shake lights and see what color light they got. A fun tip is to add music so that you can create a light show with your classroom. After students transform all of their energy into the electricity in these lights, they can better understand that since everyone drew upon the scientific principles that were learned earlier, that moving a magnet through some wire creates electricity, that everybody in the classroom has successfully created electricity on their own, and now we can all make electricity. As engineers, we draw upon the principles of science, and we take what we've learned from there and apply it in another form. Some questions for further discussion in your classroom might be, how else would you design a shake light straw so that you can have your own light show? It's all the same science, but it's just a different engineered application of the science we learned earlier. We see there's a magnet, so we know there is a magnetic field surrounding that magnet. There's some copper wire, just like the wire we used in the first demonstration, and since there's an LED attached, there's somewhere for all that electricity to go. With that in mind, we've taken our scientific ideas and applied them in an engineered device to transform our energy into the energy of the lights. For the 6th and final demonstration, we will bring back out the light rings from demonstration number 4 and help them to illuminate our power grid. Our power grid will store all the energy created from our small light rings and hopefully will illuminate a classroom. In this demonstration, you'll need 4 of the light rings, some of the banana plugs and connective wire, all of the magnetic wands, and our power grid station. In order to get this demonstration started, you'll need to hook up the wires first. So we'll put the red to red and black to black, and we'll do the same onto the power grid. Now, for this demonstration, you'll need 4 students to volunteer to come up and generate some electricity using the light rings. It's important to note, before getting started with this demonstration, that there's a switch on the light rings. This switch allows for the energy created to either flow through the wire or stay localized and light up the light ring. So a good way to test if your light ring is ready to be used for demonstration number 6 is to unplug them from the banana plug receptacles and pull the magnetic wand through the light ring. If nothing lights up, that means that the energy is going to flow through the wires. But if the switch is on the wrong side, then the light ring will light up on its own. For demonstration number 6, we want to make sure that it does not light up on its own when we use the magnetic wand. You can go ahead, reconnect the plugs, and then ask 4 students to come up and participate. Each of the 4 students will represent a different form of energy that is used all around the world. These applications of energy generation all use the same science, meaning that they have to move a magnet through some wire to create electricity. This is a mini generator, but in reality, the generators that are used to help power our classrooms and our houses are huge compared to these. And they use different sources. Instead of having people pull magnets through wires all day, they use different sources such as nuclear energy to get the magnet to move. They also use wind energy. Also, they burn coal. And another form of energy might be the waves and tidal waves in ocean water to get the magnet to move. So we've found various materials in nature to do this job for us. Because as you remember, you can't get something from nothing. So there's a lot of work that goes into generating this electricity. With that in mind, each student will be assigned an energy source. For this situation, I'll assume the role as the coal industry. So I'm currently pretending that I'm burning coal to get this magnet to move. And so for the first time around, ask only one student to pull the magnet through the wire and see if this power grid lights up. So I'll go ahead on the count of 3. 1, 2, 3. And maybe the power grid faintly lights up. So it takes a lot of energy to get this power grid to light up. Then you can ask the other 3 students to grab their light ring, grab their magnetic wand, and on the count of 3, ask everyone to pull the magnet through the coil of wire to see if energy is generated into the power grid. In this demonstration, students have to work together to generate enough power to light up our LED power grid. The power grid symbolizes energy transformers that store electricity commercially around the globe. These help us power our classrooms and our houses. Students will learn that we can all make electricity and that we're all engineers. The main principle behind this demonstration is understanding that these light rings are actually like mini generators, and that when the magnet moves through the coil of wire, it generates electricity. By using connective wire to connect our generators to a power grid, we're able to successfully collect all the energy produced from our generators and store it in this big power grid. The energy that we use to generate electricity all uses the same science, but we'll pretend that different sources are the ones that are creating the electricity. So it's a different engineered application. All these energy sources have some form of pollution, because as we know, you can't get something from nothing. But even though they're pollutants, we still need energy. This demonstration informs students on the negative implications of energy generation by source and helps participants understand how to be more energy efficient when choosing to use electricity. While using the light rings and our power grid, students can learn the NGSS PS3-4, that testing a device that converts energy from one form to another. For further explanation in a class, you can ask students to make a list of where they see electricity being used every day, then asking them, how did it get there? And finally, how can generating electricity harm the environment?